Hello. Today we are going to continue doing order of operations on a calculator, and we're introduced to a word called rational. You've probably heard of it outside of mathematics, but go ahead and take a guess on A and B. Pause the video. What do you think the root word of rational is, and what do you think rational number is a fancy way to describe? So the root word of rational is ratio, and ratio is another word for fraction. So a rational number is a way to describe a number that can be written as a fraction. It doesn't have to be a fraction already, so whole numbers work and decimals work too. As long as it can be written as a fraction, it is called a rational number. We're going to be practicing with some rational numbers written both as fractions and as decimals. I'm going to focus on the fractions. I feel like my students are usually a little more confused with numbers written in fraction form. On example 3, part A, we are adding fractions. So let's go look at this box over here. Here's how you add and subtract fractions by hand. First, you can just add them as is, but it's easier if you make improper fractions. Then you make the denominators the same by making them have the same factors. What this doesn't talk about is that after you make your denominators the same, then you add just the numerators or just the tops. So I'm going to show you what I mean by making them have the same factors over here in example A. First, let's make these either into improper fractions or really just not mixed numbers. This first number, we're going to change it into an improper fraction. And the way you do that is you got to think how many fourths are in 3. And you get that by multiplying 3 by 4, so that's 12. But then there's one more fourth. So 12 plus 1 is 13. So I have 13 fourths in total. So here's my new problem, 13 fourths plus negative 5 sixths. Now we're going to rewrite these denominators as factors, or the fancy word is actually prime factorization. So 4 has the factors 2 and 2. So 2 times 2 equals 4, and then 2 times 3 equals 6. So now we want to take the things that each denominator does not have from the other one and add them in. So in our first one, 4 does not have a factor of 3. So we want to make it have a factor of 3. And in order for our fraction to stay the same, we need to multiply by the same thing on both top and bottom, because that means that we're multiplying by 1. Remember, 3 over 3 is 1. Now let's look over here at 6. 2 times 3 does not have 2 2's, so we're going to multiply it by 2. And do the same thing on top and bottom. Let's go ahead and find out what those numbers are. So when I multiply 3 times 13, I get 39. And then 3 times 2 times 2 is 12. And then I'll have plus negative 5. Oh, it's not 5. 5 times 2 is 10 over 12. Now, that was a really easy way to get them so that they have the same denominator. They're both 12. Look at that. Now, I have 39 twelfths plus negative 10 twelfths, and I want to know how many twelfths do I have. You just add the tops. You can do this in your calculator, or you can go 39 minus 10 is 29 twelfths. Now, you have the option to just keep it this way. It is a simplified fraction. The fact that it's improper is fine. We don't actually need to express it as a mixed number, but if you really want to, you can divide 29 by 12 and get 2 and 4 twelfths. Oh, excuse me, 5 twelfths. Okay, go ahead and try example B on your own and check your answer with me. Pause the video, go ahead. Okay, so when I did B, I got negative 23 sixths. That could also be written as negative 3 and 5/6. One of the things that you need to keep in mind is that because this is a negative subtracting, your answer will be negative and it will be a bigger number. So in your head, you might think, okay, it's negative, but it's kind of like I'm adding the numbers together to make them bigger.